All right, gang, STAT1800 going to, well, I'm going to search for an ink pen right now. Going to kind of follow suit with what we did in lesson number 2. Let me see if I can get this to be a little clearer. Yeah, I don't know if we did anything or not. Okay, but the first 10 questions will be worth 50 points. And so what I'm going to do is work many of the problems for you that, with numbers changed, obviously, to kind of motivate the ideas that we're going to be covering in sampling distributions, which is lesson number 3. The good thing about lesson number 3 is I think it's easier than lesson number 2. I think that was one of the more challenging ones. So anyway, grab a calculator, and when we finish this worksheet, there's 2 pages, you'll be in pretty good position to be able to work the first 10 problems on your MyStatLab assignment. One thing we deal with a lot in sampling distributions is we deal with inequalities. So if we see something written in numbers as a number greater than 9, we can express that as an inequality, as a graph, or we can express it in interval notation. As an inequality, numbers greater than -9 would just be rewritten, or written, not rewritten, as just x, again, greater than -9. Obviously, if this was numbers greater than or equal to -9, we would be looking at this notation. We don't get into this as much because in probability and sampling distributions, we typically look at greater than or less than. Now, if we're going to do a graph, this is a lot cleaner on MyStatLab, but what I always teach students to do is to represent the number at which we're making our statement, greater than or less than. Put one number to the right. So -8 would be the one number that is bigger than -9, and -10 would be the number that is less than -9 by 1 unit. So since we want greater than, strictly greater than 9, I would use an open dot, and then some way I would represent all the numbers to the right, which are clearly greater. If, just kind of learning and passing, if you will, again, if this was greater than or equal to 9, instead of an open dot, we would have a closed dot. But again, in the context of why I'm teaching you this material, sampling distributions, which is lesson number 3, that's not as important. Interval notation, greater than -9, we would start, actually, we would have a parentheses, -9, all the way up to positive infinity. Because if we take the graph from -9 and consider it all the way, just keep going, from -8, -7, -6, -5, 0, 1, 2, 3, 4. What's the biggest number that we get out here? Well, that's actually a symbol, positive infinity. If we were looking at x greater than or equal to -9, we would use a bracket. Now on the infinity side, we always use parentheses because infinity is a symbol and not actually a number. And it's pretty easy to see that if we were going to do, x less than -2, for example, it really would help if you could see that. Then what we would be looking at is everything from, say, a -2, which would be somewhere up here. So it'd be everything this way. So it should be easy to see that in this case we would have negative infinity to the left, and then -2 would be the right-hand point. Because again, we're starting here on the right, going backwards to the left. So the negative infinity would be the left end point in the interval notation. Now, something else we see a lot in sampling distributions and normal distributions is we see a z-score. And we know that a z-score can be found by taking the value of the score minus the mean divided by the standard deviation. Sometimes these calculations give students a little bit of problem, and I want to address why most students miss these. First of all, it's simple substitution, step number 1. So x is 52, so we're going to insert that in for 52. The mean is 49, so we're going to substitute the 49 for the symbol mu, and the standard deviation is 2.8. Now, what a lot of people will do, not a lot of people, but what I see a lot of students do who are unsuccessful at this, let me type it and then I'll show you what happens and why it's wrong. A lot of students will do this, right? Order of operations says, you know what, please excuse my dear Aunt Sally, so it's going to search for multiplication division before it actually does subtraction. So what it's going to do first is it's going to take the 49 divided by 2.8, calculate that, and then subtract it from the 52. But that's not what we want, is it? If we get it, we're going to get an answer that's incorrect. What we want to happen is we want that 52 minus 49 to be, that operation to be done first and then divide by 2.8. So we don't want just the 4.9 divided by, or I'm sorry, the 49 divided by 2.8. We want the difference divided by 2.8. So in this case, we would get 1.07 as the z-score. So what that tells me is that the score of 52 is 1.07 standard deviations above the mean. All right, now, what I would like for you to do, and of course I can't force you to do this because it's online. Well, I wouldn't force you to do it if we were face-to-face. Hit pause and just see if you can work this one out. All right, so I'm going to assume you've hit pause. I'm going to assume that you have rejoined me. And a little spin here, right? A little bit of a difference. What we have now is we have that z is negative 1.42, and we have the x that's unknown, and we have mu substituted for 30, and sigma equal to 5. Now you should know, using basic algebra, that we would multiply both sides by 5. So 5 times negative 1.42. I can do this in my head, but I'm afraid that because it's an instructional video that I want to hang around for a while, afraid I'll do something silly. So on the right-hand side, we have x minus 30, so I can clearly add 30 to both sides. And I get 22.9. Now, typically, we want the variable on the left. So the x value that has a z-score of negative 1.42 is 22.9, with this mean 30 and this standard deviation. Let me get this where you can see it. Probably help, right? All right, so what a lot of times what we'll do here is, instead of working this out with numbers, we'll just go ahead and solve this thing to begin with. So if we do that, we can see that if we take z equals x minus mu over sigma and multiply both sides by sigma, these sigmas will cancel, right? So on the left-hand side, we get the standard deviation times the z-score is x minus mu. I'm going to add mu to both sides. So on the left side, I'm going to get mu plus sigma times z is equal to x, or we typically see it written as mu plus sigma times z. Now, if I insert this information from the previous problem, I have mu is equal to 30. My sigma is equal to 5. And my z-score is negative 1.42. Now, if I can put that information into my calculator without doing something silly, and so we should be able to handle that pretty easily. So 5 times negative 1.42. And we get 22.9, just as we did before. Now, make a note, tattoo this one to the brain. What I see a lot of students do is, number one, fail to use the parentheses for this part. Save yourself some trouble and frustration and do that. Another thing I see is I see students use the wrong negative sign. If you're subtracting something like 30 minus 7.1, I use this negative sign right here. But if I'm assigning something a negative, I use this negative right here. All right, so again, depends on the operation that you're trying to carry out. All right, objective number 4. We get into this a lot with proportions. So we're going to get into sampling distribution for proportions. And a lot of times we're asked to find, and it's actually an assumption that we're going to be asked to test, and we're going to be asked if n times p and n times 1 minus p are both greater than 5. Now, let me tell you what will happen. A lot of times, your textbook and my stat lab will refer to this 1 minus p as q. If it does, just substitute 1 minus p in for q, and as I'm getting ready to illustrate. Okay, so let's work on the n times p first. So if n is 0.18 and p is 0.80, I get 0.144. So no, this is not greater than 5. And if I do n times q, again realizing that n times q is actually n times 1 minus p, so n is 0.18. And 1 minus p, p would be 0.8. So what we'd have here is 0.18 times 1 minus 0.8 is 0.2. And 0.18 times 0.2, of course, is 0.036. So this one also is not greater than 5. Ladies and gentlemen, I have taught this class so many times. I've taught over 100 times at Shawnee, and probably I'm getting close to 150 or so. Don't even know, just I've taught it a long time. This is a step that the students really struggle with in terms of testing assumptions for some of the tests that we're going to run a little later on. Now, I think one of the most complicated z-scores that we get is z-scores for proportion, where we're asked to take the square root of p times 1 minus p over n. So what's that going to look like if we have, for example, a sample size of 100 and a probability, a p of 0.32? Well, first of all, it's just going to be writing the problem out. So again, substitution p is 0.32. 1 minus 0.32. I can do that in my head, but let's say that you can't. If you can't, don't sweat it. Just put 1 minus 0.32 in your calculator. It's 0.68 over n, which is 100. Now, what I will see time and time and time and time and time again is students will get sloppy here. I don't even want to write it on this paper. I don't want to mess it up. Students will get sloppy here and write this. If I had $1 for every time I've seen that happen, I'd have a whole lot more dollars. I may be ready to retire if I did. Guys, the reason this isn't the case is because in the problem that we have over here, this radical sign, this square root, applies to everything here in the fraction. The 0.32 times the 0.68 divided by 100. So we have to figure out a way in our calculator to put all of this in our calculator. And it turns out that it's just pretty easy to do. So just go grab the square root, and I need 0.32 times 0.68 divided by 100. So I need evidence in my calculator because depending on the operating system that you have, your calculator could give this in a different form. And I'm going to show you a way to check that if your calculator isn't as straightforward as this one is. So I hit enter and I get 0.047 depending on what my stat lab tells us to round to. So let's say it did tell us to round to 3 places. Since that's 6, this number to the right is bigger than 5, this would round up to a 7. So 0.047, again, assuming that my stat lab indicated to round to 3 places. Now, another thing that you could do, if your calculator isn't as straightforward, in these situations right here, you could rewrite this like this. We have a property that says the square root of a over b is the same thing as the square root of a over the square root of b. So what you could actually do in your calculator is you could take the square root of 100, which is 10, and then the square root of 0.32 times 0.68, which is 0.466. So I have that here, and then I could just divide by 10, or if it was something that didn't have a nice square root, I could just do that and still get 0.0467 as I did before. All right, let's have some fun. I'm really interested in who is watching the videos and who isn't. I'll just tell you I am. And to help me, and by the way, I told you in the introductory video, there's a requirement for the class, just like coming to class, attending class. Since we're not face-to-face, we're online. The equivalent of attending class is watching the instructional videos. So what I'm going to do, all the sneaky quizzes up to this point are pulled over into a file, and at the end of the semester, if you need a couple of extra points, I'm going to go to that folder. And again, I've explained all this in the introductory video, but I'm going to go to that folder. I'm being a little redundant here. I'm going to go to that folder, and if you've turned in most of the sneaky quizzes and you need 2 points, maybe even 3 to get the higher grade, you're going to get it. If you haven't been watching the videos, then my rationale, my logic is, well, this person wouldn't even need the extra 2 or 3 points if they had just watched the videos and been responsible and done what I asked them to do. Well, actually, what you're required to do. So I'm going to make this, I don't know, let's make it a 25-point quiz that is actually going to count in my stat lab. You're actually going to look in my stat lab, and you're either going to see a 0 out of 25 or a 25 out of 25, depending on if you submitted this and submitted it correctly. So what I want you to do is I want you to work this problem. So just email to me just the answer. If this was the answer up here, just type 0.047, sneaky quiz, whatever you want to call it, and I'm going to go to my stat lab and I will give you credit. So email it to me, ddarbro@shawnee.edu. If you can't read my writing, go to the syllabus, and it's all typed out there for you. And I want you to calculate the z-score when n is equal to 250 and p is equal to 0.82. It's the same question exactly as this one up here, just numbers changed. Plus, it's going to give you a few extra bonus points, if you will, for watching the videos. All right, gang, that's all I got. Hope everybody's doing well. I hope you're enjoying the class. So stay well.